unlucky is it that I have to film for my video, but it's raining?
So, are you just going to complain? Or would you actually want to know why things like this happen?
Why don't we look at things at the most fundamental scale, the quantum scale, and let me explain things through a quantum description of reality.
One of the most successful attempts in describing quantum systems is the Copenhagen Interpretation. Niels, Bohr, and Werner Heisenberg say that randomness is a fundamental fact of nature. And because of randomness, it is impossible to define properties without measurement. You can only predict. In a quantum system where light passes through a small slit one photon at a time, where the photon will end up in a screen can be described with a set of probabilities or predictions. Here you have a high chance of finding it positioned in the middle and a low chance of finding the particle in these areas. The higher the amplitude, the higher the probability. During measurement, the wave function collapses into the measured state as we no longer have any need for the other probabilities.
I use the weather to describe quantum systems because just like small particles, the weather isn't something whose properties we can completely describe.
There is another way to explain quantum systems, and that's the many worlds theory, where Paul Davies, theoretical physicist, describes it as cheap on assumptions, but expensive on universes.
Here, timelines branch out with respect to even the tiniest interactions we know of, creating universes, each with their own combination of events. Unlike the Copenhagen Interpretation, which says that things just happen out of randomness, here things happen because you're in the universe where it happens, resolving many of the puzzles and paradoxes of the measurement problem in the Copenhagen Interpretation, where we fail to identify causal relationships in a system.
But you can actually use the many worlds theory and explain the Copenhagen Interpretation.
See that the Copenhagen Interpretation relies on the wave function.
And the wave function looks like this because it is a superposition of the different states of the weather. At some points the waves add up, and at others the waves cancel. The reason why the wave function can't look like this is because it says that there should be equal probabilities of it raining at different times. But adding more and more waves makes the region when there's a good probability of it raining become narrower. Squaring the wave function gives us the probability function and presents us with a good prediction of when it will be raining.
See, quantum mechanics can actually make sense out of my bad luck. One theory tells me that it's just pure randomness. Another suggests that I'm just a bad luck version of myself out of an infinite many. But that implies that we no longer have to worry about anything at all because everything's already been set. How are we so sure? I hope you enjoyed learning about the quantum descriptions of reality. Thanks for watching, and I'll be seeing you next time.